Okay, so now for example number 2, we're asked to integrate this fraction. It's not easy. Alright, so to integrate a quotient is not easy the way that it's written. What I'd like to do is separate this with partial fractions. So the first step in this is to figure out, I could factor the bottom into x plus 1 and x minus 1, but if you look in the top, that doesn't really help. I mean, it does, but it doesn't. Another technique I could do is, remember, this is the same as saying 3x to the 4th plus 1 divided by x squared minus 1. Now, if I do long division, I'm going to multiply by 3x squared, because 3x squared times x squared gives me 3x to the 4th power. So that gives me a positive 3x to the 4th power, but I also have to remember to multiply that by the negative 1. So I'm kind of distributing the 3x squared through the parentheses, and that gives me a negative 3x squared. And so I'm going to subtract those terms, so I change the signs. These cancel, and now I have 3x squared plus 1 down here. Well, again, I'm going to multiply that by a positive 3. And that will give me 3x squared, right, minus 3. Then when I subtract, I change the signs of those. These cancel, and I get a positive 4. So that same expression is the same as 3x squared plus 3 plus the remainder over the divisor. Well, that's nice, because now I can take those and integrate each one separately. So if I think of this in terms of integrating that as a function, I could take the integral of 3x squared, plus the integral of 3 plus the antiderivative of 4, but now I'm going to factor it and get x plus 1 times x minus 1. Okay? Well, now the antiderivative of 3x squared is going to be 3x to the 3rd power divided by 3 plus, this is just going to be 3x to the 1st power. And then I've got to do this business here, which would be capital A over x plus 1 plus capital B over x minus 1. And so now if I solve A and B, that hopefully will help me out, because whatever those denominators are, they're raised to the 1st power, and I could toss the constant. Well, you'll see when we get there. So now I'm gonna address this issue here. So I'm going to focus all my attention on solving what A and B are, and I'm going to use a different sheet of paper. So I'm going to really just kind of harness in on this, focus in on that. So I got to solve for A and B. Well, A plus B has got to equal 4, right? So what I'm saying is that A over x plus 1 plus B over x minus 1 has to equal 4 over x plus 1 times x minus 1. Well, now to get the common denominator on this one, I'm going to have to multiply the top by x minus 1, and I'm going to have to multiply the top of this one by x plus 1, right? Because that's how I get my common denominator, x minus 1, and then x plus 1. Okay. So I'm left with A times x minus 1 plus B times x plus 1 has to equal 4. Well, if I let x equal positive 1, then I get A times 0 plus B times 2 equals 4, or 2B equals 4, which means that B is equal to 2. Now I got to solve for A. So if I start over and I say A times x minus 1 plus B times x plus 1 is equal to 4, and I'm going to let x equal negative 1, Then I get negative 2a plus b times 0, which goes away, is equal to 4, so a equals negative 2. So this next line here, I'm going to plug in b equals 2 and a equals negative 2. So the 3's cancel here, so on my next line I've got x cubed plus 3x, right? And then I'm going to add the integral of negative 2 over x plus 1 plus the integral of positive 2 over x minus 1. Now, if I want, I can think in terms of how would I solve that? If I toss the 2 to the front on the integrals, which I can because of the properties of integrals, in my next line I get x cubed plus 3x, and then this is minus 2 times the integral of 1 over x plus 1 plus 2 times the integral of 1 over x minus 1. Well, that's the natural log of u, right? So we know that 1 over u, if I take the antiderivative of that, it's the natural log of u, and that's pretty much it. So if I say x to the third power plus 3x minus 2 times the natural log of the absolute value of x plus 1 plus 2 times the natural log of the absolute value of x minus 1, and then we have to tack on the plus c, which seems kind of long, but I can use the properties of logs because I have the same base, which is the natural log. So to simplify that, I might say x cubed plus 3x, right, plus 2. If I factor out the 2, I get the natural log of this, and then minus, or this would be negative and that would be positive. So then that would be 2 times the natural log of the absolute value of x minus 1 all over x plus 1, and then we tack on the plus c. So that's technically the antiderivative. Any questions?